Hello everyone, today we are solving the TIFR 2024 solution. We are starting from question number 5 today, and the question is very easy. So let f 0 to infinity be a continuous function and this runs from 0 to 1, then which of the following sentence about the limit is correct? Okay, so to solve this question we need to analyze the given information. The problem said f to 0 to infinity they have given. So limit n tends to infinity 0 to 1 f of x plus n dx is equal to, simply this is given as 2. So the condition implies that n approaches infinity and integral f of x n over the period 1 to 0 converges to 2. So we need to determine the behavior of the limit. So limit n tends to infinity 0 to 1 f of nx dx. So first we make substitute u equal to nx, okay, which implies du equal to n dx so then the integral becomes very easy, 0 to 1 f of nx dx, so 1 by n 0 to n fu du. So now we need to consider the behavior of the function fu as u approaches to infinity. So fu is a bounded and u approaches to infinity. U approaches to infinity, fu is bounded. So the limit of the integral 1 by n, so this thing will be 0, so as n approaches infinity. So this is because of the interval 0 to n is expanding, the function fu remains bounded. So 1 by n goes to 0. So however, fu is unbounded. If it is unbounded and as n approaches infinity, then the limit of the integral may not exist or may approach to a non-zero value. So given this condition, limit n tends to infinity 0 to 1 f of x plus n dx equal to 2. So it is possible that the limit n tends to infinity 0 to 1 f of nx dx also exists, and that is equal to 2. So therefore the correct option is C. Now let's proceed to question number 6. The function such that this thing is given, function e subset of r, summation of fx less than equal to 1, let cf equal to this function. Then what is CF? Finite, infinite, bounded, formula instead. Okay. So here in this case, to show that CF is, we calculate the first work on the following reasoning. So since this summation of f of x is bounded by 1 for any finite set E, so it seems that fx cannot be greater than 1. So this has to be less than 1, okay, for any x belongs to R. Second is fx greater than 0, if 0 less fx less than equal to 1, okay. Then the set of real numbers between 0 to 1 are uncountable. However, the set of CF, so the see that the set contains only those x values. So next part is, however, CF contains only those values, x values. Okay. So 0 to 1 we can take it, and CF has a subset of all real numbers also, 0 to 1, so it cannot contain an uncountable number of elements. So CF must be an uncountable set, so therefore in this case only D is the correct answer. Let's proceed to question number 7. So let P be a prime, okay, P is a prime. Which of the following is true? Again a theoretical question. So there exists a non-commutative ring with exactly p elements, p square elements, and none of the remaining statement is the correct. Okay, so there exists a, they have said, non-commutative ring, okay, of exactly p elements. This is not always true. For a ring to have prime number of elements, okay, it is typically needed to be a field. This is for sure. So a special type of ring with some additional properties. So most fields, including those with p elements, are commutative, and elements can be multiplied in any order. So this one is wrong. First one is wrong. So there exists a non-commutative ring with exactly p square elements. So now here there exists a non-commutative ring with p square elements. Similar to A, p square elements doesn't guarantee a non-commutative ring. So however, there might be some specific construction of certain primes, but it's not generally true. So this is wrong. C is correct actually. We can construct rings with p to the power 3 elements using the matrix rings. Okay, using the matrix rings. Now consider a ring of size of 2 into 2 over a field with p elements denoted by maybe fp. Okay. So the ring will have a p square number of elements such that 2 into 2 matrices with the entire form. Now we define a specific constraint on these matrices. Forever consider the matrices where top right entry is always 0. Okay, so whatever a top right is always 0. So this restriction ensures that there is only p square possibilities, p square number of possibilities of the remaining entries can take p possible values. So within this constraint, multiplication of these matrices become non-commutative. As a result of that, we can have this thing as an answer. Okay, so therefore by restricting the matrix and a position, we can reach to this. The last one is not the answer again, because none of the remaining, because we have already got it. So C is the correct answer. So let's proceed to the next one as question number 8. So here consider a sequence an equal to limit n tends to infinity of summation of 1 by k square. So what you can tell about the existence of this limit? Okay, here we go. So this sequence is formed by taking n tends to infinity. So the arithmetic mean of n terms of the series, am of n terms. So am we have taken. So the sequence formed by taking n as goes to infinity. So here is the sequence. So we know that this particular sequence converges to here pi square by 6. This is a famous result in calculus, you can do it. As n goes to infinity, arithmetic mean of this thing, so like 1 by n summation of k equal to 1 to n, sorry, n to n, 1 to n, 1 by k square, will approach the value of the sum of the infinite series, which is also again pi square by 6. So this is directly pi square by 6. Since pi square by 6 is 1.644, so we can conclude that limits exist and equal to 1, which is option number C.